Hello again, Miss Garcia here. Today for 4.7, more proofs on all of our different theorems that we've learned about proving two triangles congruent. Now, from what I understand, this page 25 here, Miss Lauderdale had planned for you guys to work on this one on your own. So I'm not going over that today. I am going to do the proofs that are on the next couple of pages. Now, these proofs are a mix of all of our different methods for proving the triangles congruent. The ones we've had, or all that there are for us to use. As a reminder, we had side, side, side. We had side, angle, side. We had angle, side, angle. And angle, angle, side. And then for right triangles, HL, hypotenuse, leg. So these proofs here could be any one of those five. And so we have to look at the diagram and think it through, work through which one of those are we able to use based off of what the diagram looks like and what they're giving to us. So let's start this first one, number one. We're supposed to be proving that MKL is congruent to PNL. All right. So let's start with our first given. It says L is the midpoint of KN. Oh, and MP. So it's the midpoint for 2. That is given. So let's do the first one first. It says L is the midpoint of KN. Hopefully you're remembering that once they say some point is a midpoint, the very next thing that you can say is that the two halves are equal to each other. So that's going to be my very next statement that I make. So those sides colored in blue now, KL is congruent to NL. And you remember what the reason would be? Definition of midpoint. Once they tell you something's a midpoint, you then, right after that, you say that the two sides are congruent. All right, so that was, we were able to say KL and NL are congruent because L was the midpoint of KN. But they also told us it's the midpoint of MP. So L is also the midpoint of NP. So because of that, we can say those two halves are equal to each other. So let's name those as our next statement. Segment ML is congruent to PL. Again, because of the definition of midpoint. Okay, look at our diagram. We have two sides, side, side. Hopefully you've recognized it so far. Remember, when we have two lines crossing each other, we can say that the two angles are equal to each other. So by vertical angles. So that angle equals that one that I just marked in red. So let's name those. The one on the left, angle MLK, is congruent to triangle angle PLN. And that is because vertical angles are congruent. All right, so we have side, angle, side. Side, angle, side. Now we can write out that they're equal. Congruent rather. Triangle MKL is congruent, and I'm just copying what it says up here to prove. Triangle PNL. By side, angle, side. All right, please pause the video and try this next one, and we'll have you do that for each of these today. All right, we've got a new diagram here. We're supposed to be proving that ABD is congruent to CBD. So two triangles again, and they're sharing a side, so I bet you we're going to have to use that. Our first statement, BD bisects angle ABC given. All right, BD bisects angle ABC. Okay, so just like when they tell you something's a midpoint, your automatic statement after that is the two sides are equal. Just like that, if they give you that a segment is bisecting an angle, we say right after that, our statement is that the two angles, the two halves that the bisector is cutting are equal, congruent. So let's name those. The one on the left, angle ABD, is congruent to angle CBD. And that is by the definition of angle bisector. All right, so we had a statement that it's a bisector, so we can say the two angles are congruent. We do have another given, so let's list that one next. Angle BAD is congruent to angle BCD. BAD is this guy, congruent to BCD, that guy. So they're marked on my diagram. Got to write that the reason is given. Okay, so looking at our diagram, we've got two angles, and as I mentioned in the beginning, they are sharing a side. So remember that when the two angles are sharing a side, you want to use that to be a side in your proof, and you've got to say that that side equals itself. BD is congruent to BD. And the reason for that is the reflexive property. And look at that. We've got angle, angle, side. Angle, angle, side for each of our triangles. Angle, angle, side. That was the second to last one that we learned. So now we can write that the triangles are congruent. Triangle ABD is congruent to triangle CBD by angle, angle, side. Alrighty, number 3. Let's see what we have here. S is the midpoint of QU. Given. S is the midpoint of QU. Just like above in number 1, when they tell us a point is the midpoint, then our next thing that we've got to say is those two halves equal each other. So let's write that as our statement. QS is congruent to SU. Definition of midpoint. All right, so we've got two triangles, and so far we have one pair of sides that are congruent. We do have more givens. QR is congruent to ST. Let's get it written down and then we'll do it on our diagram. QR is congruent to ST given. QR is congruent to ST. I should have done double slashes since I used the single slash on those sides because they're different from each other. Okay, we've got side, side, and we still have another given. Let's put that one down. RS is congruent to TU. RS, now I have to use 3 slashes, is congruent to TU. And that's all laid out for us, side, 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 in each triangle. So we can now write that they're congruent. Triangle QRS is congruent to triangle STU by SSS. And I forgot to write given for number 4 there. Side, side, side. Very good, very good. Pause the video and try number 4, please. And here we go. We are trying to prove that FGH is congruent to FJH. Top triangle to bottom triangle. Let's start with our first statement. F triangle FGH and triangle FJH are right triangles. Given. Okay, so that's telling us that each one is a right triangle. So I'm remembering all my theorems, and the one that uses a right triangle is HL. So we would need the hypotenuse and a leg. So let's see where this takes us. I can't say any more statements based off of just that these are right triangles. So I'm going to go to the next given. GH is congruent to JH. GH is congruent to JH. Given. Alright, so we've got that they're right triangles, and we've got a side, or a leg rather. Hopefully you've noticed what you can do next. This guy, FH, is sharing a side. It belongs to the top triangle and the bottom triangle. So I need to say that that side equals itself, is congruent to itself. FH is congruent to FH by the reflexive property. And that's it. We've got HL. We've got the hypotenuse is opposite the right triangle, and we have another leg in the triangle. So this one didn't take all 5 of the steps here, and that's okay. Triangle, because we have what we need. Triangle FGH is congruent to triangle FJH by HL, hypotenuse leg. Okay, please pause and try number 5 and come back to the video after everyone's given it a try. Okay, we're supposed to prove that KML is congruent to PMN, top triangle to bottom triangle. And our first statement here, KL is parallel to NP. given. So KL is parallel to NP. I'm marking that on there. Now remember what I said, there's just a few, in all of these proofs in this whole chapter, there's just a little handful of things that you'll have to remember. So one is that if they say that there's a midpoint, a point is a midpoint of a segment, you then, right after that, say that the two halves are equal. If they give you that a segment is an angle bisector, then you come along and say the two halves, the two angles are equal to each other. Vertical angles is another one. If two lines are crossing, you can say vertical. And I think that was it. And now for the parallel lines. So if we have two parallel lines with a transversal, depending on what the diagram looks like, either you can find corresponding angles or alternate interior. So what do you guys notice in this one? Well, hopefully you already practiced through it. So I'm looking at this transversal, and so I can say that those two angles are equal to each other because they're alternate interior. So I'm going to say that next. Angle, and I don't need to use the three letters because there's just one angle coming off of that vertex L. So L is congruent to angle N. Alternate interior angles are congruent. All right, so we have just one pair of equal congruent angles. We do have another given though, so let's put that in there. KL is congruent to PN. Given, and let's mark it on our diagram. KL is congruent to PN. Okay, let's see what we have here. We have a side and an angle. I'm going to write down our choices again. I'll do it along the side here. Our choices are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So I have one side and one angle. And now I'm looking to see what we have. And I had mentioned the two lines crossing, and you can make vertical angles. So we have those two. And so our pair of vertical angles would be those two. And that would give us two angles and a side. Angle, angle, side. So let's get her down. The top black angle, I'm going to call it angle KML. And that is congruent to the bottom corresponding angle would be angle PMN. And that is by vertical angles are congruent. And so our diagram and in our proof we've got angle, angle, side, angle, angle, side. Now we can write down what we've proven that, or what we were supposed to prove, that triangle KML is congruent to triangle PMN by angle, angle, side. All right, just one more. And please pause the video and try it on your own, and then replay to go over it. This is an interesting diagram. We haven't seen one looking like that yet. We are supposed to be proving TVY is congruent to XWY. So the triangle on the left and the triangle on the right, the smaller ones. Okay, let's start with our first given here. TY is congruent to XY. Given TY on my diagram is congruent to XY. All right. Let's go on to the next given. Angle TVY is congruent to angle XWY. TVY is that angle, XWY that angle. All right. Do you see anything in the picture that would allow you to say anything else is given or equal? I forgot to write given right there. So I am seeing vertical angles because we have our two crossing lines there. So, and that will give us angle, side. So let's name those. Angle VYT is congruent to angle WYX. By vertical angles. Vertical angles are congruent. And so we have angle, side. Again, didn't we just use, yep, another angle, side on this one. So, statement 4, triangle TVY is congruent to triangle XWY by angle, side. Oops. Just put angle. There's no angle. Angle, side. All right, you guys, that is it for today. I just want to look and see the homework because there's two, if you notice, there's 2 more pages. Let me just go back to where I was. There's 2 more, or maybe even 3. Nope, 2 more pages, but I think we're going to save this section for another day. So I want to look at your homework and see if there's, actually I need to look on mine with the answers. Hold please, because I want to shorten up this homework if there's any that use the parts that we skipped. Yep. Okay, so you guys are going to be happy for this. So your homework for tonight is only page 43. So page 44, all of these use what we call CPCTC, corresponding parts of congruent triangles are congruent. You don't need to know that right now. That's the part we're skipping. So, because I didn't want it to be too much in one day. So, we may either skip that altogether or come back to it another day. I will let you know, or Miss Lauderdale will let you know. So, for now, we're just taking notes on page 26 and 27. And your homework is only page 43, and we will let you know if we do notes on 28 and 29 at a later date. And that's it for today. Have fun and do your homework. Come and see me in 214 if you have any questions.